We're on lesson 4 of chapter 5, in which we'll solve compound inequalities. First, we'll write and graph compound inequalities. Then we'll solve compound inequalities with and or, and then solve a real-world problem. When it's compound inequalities, it has to meet two or more certain conditions. For example, when it's an and, x needs to be greater than or equal to negative 5, and x is less than or equal to positive 5. We could plot out both number lines here, greater than negative 5 and less than 5, and it has to meet both of these. These are the only numbers that meet both of those conditions where you see the dotted line. Everything here only meets one of those, so this would not be a solution, only between the two dots. And this is shown by this. Negative 5 is less than or equal to x, which is less than or equal to 5. And it's this green line right here where it meets these conditions, which is between these two numbers. Ors are different. They could meet either one of the conditions and then you would be okay. So if x is less than negative 5 or x is greater than 5, we'd have open circles at negative 5 and 5 going in this direction, which is less than negative 5, or this direction, which is greater than positive 5. Anything on either of these lines would be okay. Anything where you don't see a line would not be a solution. So let's give these a shot. It says translate the verbal phrase into an inequality and then graph it. It says all real numbers that are greater than negative 2 and less than 3. So we can use x to represent the numbers. We have x greater than negative 2 and x is less than 3. And then if you're going to write this out, we can go from least to greatest. Well, I know negative 2 is going to be the smallest, so negative 2, which is less than x, and then x is less than 3. So here's our statement that we want to write it like. Let's start with my 0 in the center. Then I could do my open circles at negative 2 because it's only greater than, and at positive 3 because it's less than. My greater than arrow goes this way. My less than arrow goes this way. And remember, it has to meet both conditions. It's an and, so it'd only be the ones where they intersect here, which would be between the two dots. Now we have an or problem here. All real numbers that are less than 0 or greater than or equal to 2. So we could write this out. X would be less than 0 here, and then x would be greater than or equal to 2. So we'll draw that line. And for this one, you can't really write a nice, neat phrase like this, so all you need to do is put an or between here. Then we can graph both of these. Then we can number this at 0 again. Then we can do an open circle at 0 here. And we know that x would be less than that. Then we'd have a closed circle at positive 2. And we would see that x is greater than that. So we have arrows going in opposite directions, and it says it could be either or, meaning if it's here, it's okay. If it's over here, it's okay. But in between 0 and 2, it would not be okay. It could be 2, but it can't be 0 because that's an open circle. So this would be the graph of this inequality. So when it's a phrase like this, it's the and inequalities. When it's a phrase like this, when you see the or, it's an or. Just keep that in mind. We have to solve this one then. We have 2 is less than x plus 5, which is less than 9. When we isolate the x by subtracting 5, we need to subtract 5 from both sides of these inequalities then. So we're actually subtracting it 3 times. So 2 minus 5 would be negative 3, which is less than x, which is less than 9 minus 5 is 4. So this would be my new statement. Then I could plot this out. I'm going to do 0 and count by 2's this time. So I'm going to do my open circle at negative 3, open circle at positive 4, x is greater than negative 3, and x is less than positive 4. So they're going to crisscross again, and then these would be the solutions between 4 and negative 3. Let's solve this one. We have negative 5 is less than or equal to negative x minus 3, which is less than or equal to negative 1. First, we're going to add 3 to all sides. So I'm left with negative 5 plus 3, which would be negative 2, and that's less than or equal to negative x, which is less than or equal to positive 2. So here, to get this into a positive x, I have to divide by -1. Remember, when you divide by a negative, you got to flip these. We'll have to flip both of these, actually. So we divide by -1. That'll give us +2 over here, which is greater than or equal to x, which is greater than or equal to 2 divided by -1, which would be -2. So everything got flipped there. I made this positive, and then these got flipped as well. So if we make this 0 and count by ones, we could plot a closed circle at +2. We can plot a closed circle at -2. We see that x is less than or equal to +2, so we'll plot that line. We also see that x is greater than or equal to -2, so we'll plot that line. And where we see this intersect is where our solutions can be. Remember, it's an and, so it has to be both. One more. We have 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. So here they're separate. So I can solve these separately. I'm going to solve them up in the upper right corner here. So we have 2x plus 3 is less than 9. Subtract 3 from both sides. That gives me 2x is less than 6. Divide both sides by 2. And that would give me x is less than 3. So I'm going to rewrite this down here. X is less than 3. And then give myself some room again. So I have 3x minus 6 is greater than 12. I would add 6 to both sides. So I'd be left with 3x is greater than 12. Divide both sides by 3. And I'm left with x is greater than 4. So I have x is greater than 4 over here. So if I put the or in the middle, I have my x is less than 3 or x is greater than 4. If we start with 2 in the middle, for example, and then count by ones, then I could plot my points. They'd both be open circles. So open circle at +3, open circle at +4, and then x is less than 3, so we're going to go that way, or x is greater than 4. Since this one's an or one, if it's on either of these lines, it is correct, but that means anything between 3 and 4 is not a solution to this inequality. So it says the Mars exploration rovers Opportunity and Spirit are robots that were sent to Mars in 2003 in order to gather geological data about the planet. The temperature at the landing sites of the robots can change from -100 degrees Celsius to 0 degrees Celsius. It says write a compound inequality in degrees Fahrenheit. That's different from Celsius. What kind of compound inequality would this be? Well, it needs to be greater than -100 degrees and less than 0 degrees Celsius. So that kind of gives it away. It's an and. So we'd have -100 degrees. -100 in Celsius would have to be less than the degrees in Fahrenheit, which would be less than 0 degrees in Celsius. Remember, I have to convert this all into Fahrenheit, though, because remember, Celsius and Fahrenheit are different. How do I turn Fahrenheit into Celsius? We have that formula, right? It's 5/9 times the Fahrenheit temperature minus 32. So if I undo this by having it go to both sides, I could solve this problem. So let's make this a little smaller. Then we could solve it up here. I can get rid of this first by multiplying times the reciprocal, 9 over 5, to all sides. 9 over 5 here, 9 over 5 here. So that would turn into 100 times 9 divided by 5 would be -180 is less than the degrees in Fahrenheit minus 32, which is less than 0 times 9 over 5 would be 0 still. Then we could add the 32 to both sides, or all sides I should say. We have -180 plus 32. That'd be -148, so -148 is less than the degrees Fahrenheit, which is less than 0 plus 32, which is 32. And I'm actually going to say less than or equal to here, because it could be exactly at that temperature. So if I'm going to plot out my points, I'm going to start at -200 here, and we're going to count by 50s. Okay, so if I plot my points, I need a closed circle at negative 148, which would be right about here. And then that's less than f, or f is greater than or equal to that, so we're going to go in this direction. And then I need a closed circle at positive 32, which is right here. And then 32 is greater than or equal to f, so we're going to go in this direction. So the robots have to be between negative 148 and positive 32. So three possible temperatures. I could say negative 100 is a possible temperature. I could say negative 50. And I also could say 0 degrees Fahrenheit too would be just fine. So to recap, I did the compound inequality with Celsius degrees here, and then the formula for Fahrenheit into Celsius right here. Undid that formula. Then I solved the inequality from there, which gave me negative 148 is less than or equal to f, which is less than or equal to 32. And then the solution is found in this area right here between the dots.